Good morning, Algebra. How are we doing today? I hope that we're having a great start to our day, and let's talk about some more inequality stuff. Last time we talked about how do we graph them, a little bit about what they are, and this time we're going to be talking about how do we solve them, right? Especially when we are thinking about solving them using addition, subtraction, multiplication, and division, all of that, okay? So we're going to be talking about all of those things in this video. So without further ado, let's get to the video.
Today, we're going to be talking all things about solving inequalities. So we're going to talk about using addition or subtraction to solve them, and we're also going to talk about solving them using multiplication or division. But let's start with addition or subtraction. So in this first part, I'm hoping that by the end of the video, you're able to use addition and subtraction to solve inequalities. So let's always start with our key concepts and vocabulary. Our two key concepts and vocabulary for this video in the beginning are the addition property of inequality and the subtraction property of inequality. Now, these essentially work the same as the addition property of equality and the subtraction property of equality. So if the same number is added to each side of a true inequality, then the resulting inequality is also true. And then if the same number is subtracted from each side of the true inequality, the resulting inequality is also true. So I'm going to solve a couple, and then we're going to talk about a couple others from there. So if we remember from our last video, we need to have an open dot when we have a less than or greater than sign, and we need to have a closed dot when it's less than or equal to or greater than or equal to. So let's start off by solving A and C. So I'm going to highlight those really quick. So I have x minus 12 is greater than negative 8. Now, when I'm trying to solve inequalities, I can essentially treat the inequality sign as an equal sign, as in I can still add or subtract quantities from the left-hand side to the right-hand side and vice versa, as long as I'm doing the same thing on both sides. So the way that I would solve for x is I would add by 12 on both sides. And I would ultimately get that x is greater than or equal to negative 8 plus 12 gives me positive 4. So I need to graph the solution. So what I'm going to do is I'm going to make this be a 4. I have an open dot, and I know that x is going to be greater than 4, so it's going to the right. Simple as that. Okay, so let's try part C. I have 22 is greater than x minus 8. Again, next thing I need to do is I just need to add by 8 on both sides. And I get 30 is greater than x. So I'm going to put this line as 30. So I have an open dot one more time, and then my arrow is moving to the left. Let's try a couple more examples. So solve and graph each solution. So what I'm going to do, I'm going to make this line a little smaller here for me, and I'm going to go ahead and I'm going to solve A, C, and E for us. So we have y plus 3 is less than 7. Again, I can still use my ideas of solving these inequalities like they were an equal sign. So what I'm going to do is I'm going to subtract by 3 on both sides, and I get y is less than 4. So what I need to do is I need to put an open dot. Y is less than 4, which means that it's going to the left. Part C is a little different because it's got fractions in there, but don't let that confuse you. Okay, so I have D plus 4/7 is greater than 1/14. What I'm going to do is I'm going to rewrite this problem, and I'm going to make it D plus 8/14 is greater than 1/14. And I did that because I just want to have common denominators. So I'm going to subtract by 8/14 on both sides. And I get D is greater than negative 7/14, which is the same thing as D is greater than negative 1/2. So I'm going to put an open dot on negative 1/2. D is greater than that, so I move my arrow to the right. Part E. 9 is greater than or equal to 5 plus r. So if I'm trying to solve for r by itself, that means I need to get rid of the values that are around it. So I need to subtract by 5 on both sides. So minus 5, and I get 4 is greater than or equal to R. So I need to have a closed dot on 4. R is less than or equal to 4, so I move my arrow to the left. Okay, let's try a story problem here. Example 3, you have been saving for a new phone that costs no less than $200. You have saved $130. Write and solve an inequality to determine the amount you need to purchase this phone. So I know that I have $130. If the cost is no less than $200, that means that it's going to be at $200 or more. So I know that this is going to be greater than or equal to 200, and my amount of money is plus X because that's what I'm trying to figure out. So I have $130 plus the amount that I need to have is greater than or equal to $200, the cost of the phone. Okay, so what I need to do, next thing I need to do is subtract by 130 on both sides. So I have X is greater than or equal to $70. So I know that you need at least $70 to purchase the phone. So those are all my examples for adding or subtracting in scientific notation, but let's go ahead and talk about multiplying and dividing. So in this next part, I'm hoping that by the end of the video, you are able to use multiplication and division to solve inequalities. And let's go back to our key concepts and vocabulary. Again, we have the multiplication property of inequality and division property of inequality, but things are different here. So it's super important for us to see in this first part, if the same positive number is multiplied by each side of a true inequality, the resulting inequality is also true. And that's the same thing for division, but things get a little different when I talk about negative. So if the same negative number is multiplied by each side of the inequality sign is reversed to make the inequality sign true. And that's the same thing for division. So whenever I multiply or divide by a negative number, I need to reverse my inequality sign. So for example, let's say I had x or negative x is less than or equal to 4. If I multiply both sides by negative 1, this becomes x is greater than negative 4. Okay, so let's do a couple of other examples, and I've already highlighted some examples for us to kind of keep going. So I'm gonna work on my highlighted examples. So example number 1a, I have x over 4 is less than or equal to 3. I just need to try to solve this. Now remember, when I'm trying to eliminate a fraction, I can multiply by my lowest common denominator. In this case, that means that I can multiply by 4 on both sides. So let me rewrite the problem here. I'm going to multiply by 4 on both sides. My denominators cancel out, and I'm left with x is less than or equal to 12. Let's try this for c. So I have 1/3 x is less than 2/3. Again, I'm going to try to multiply by my lowest common denominator, which in this case is going to be 3. So if I multiply both sides of the equation by 3, the denominator on the left-hand side cancels out, and I'm left with just x. My less than sign stays the same because I'm not multiplying or dividing by a negative number. And then 2/3 times 3, those 3's cancel out, and I'm just left with 2. Let's think about example number 2. I have x over negative 5 is greater than 4. So what I'm going to do, multiply by my lowest common denominator. So that means I need to multiply both sides by negative 5. So my negative 5's cancel out, and I'm left with x. But since I've multiplied by a negative number, that means my inequality sign has to reverse. So what was once greater than is now going to be less than, and 4 times negative 5 is negative 20. Let's show my work for part B on this other side. So this is the same thing as negative x over 2 is the same thing as x over negative 2 is greater than or equal to 6. Again, I'm going to multiply by my lowest common denominator, which is negative 2. I'm multiplying by a negative number, which means I automatically reverse my inequality sign. So instead of a greater than or equal to sign, like I have right there, it flips and becomes a less than or equal to sign. My negative 2's cancel out on the left-hand side and my x drops down. And 6 times negative 2 is negative 12. So I know that my final answer, x, is going to be less than negative 12. In example number 3, solving inequalities using the division property. So again, these are still one-step equations. So if I'm trying to solve for m, for 2m is greater than or equal to 6, I just need to divide both sides by 2, and I'm left with m is greater than or equal to 6. My inequality sign stays the same because I'm not dividing by a negative number. For part B, I do something similar. In this case, I'm dividing by 4 on both sides, and I'm left with A. Even though I'm doing negative 12 divided by 4, the actual number that I am dividing by is not negative. So my inequality sign stays the same. So this becomes A is less than negative 3. A couple more example problems here, and then we will wrap up. So example 4, solving inequalities using the division property with a negative number. So part A, solve negative 5t is less than or equal to 55. So again, I'm going to divide both sides by negative 5 here. And since I'm dividing by a negative number, I know that my inequality sign is going to reverse automatically. So what was once less than or equal to is now greater than or equal to. My t drops down. And 55 divided by negative 5 is negative 11. So I know that t is greater than or equal to negative 11. Last question in example 4, I have negative 9x is greater than negative 72. So what I'm going to do is I'm going to divide both sides by negative 9 because it's the opposite of negative 9 times x. I know that since I am dividing by a negative number, sorry, that 9 looks a little bit like a 7. There we go. Since I'm dividing by a negative number, my inequality sign reverses. So since it was greater than, it's now going to be less than. My x drops down, and negative 72 divided by negative 9 is positive 8. And then we just have one more problem for us to do. Okay, so let's scroll up here. You work at a local car wash and make $8.25 an hour. How many hours do you need to work to make at least $165? Okay, so a minimum of $165, which means you are going to be greater than or equal to 165. And you make $8.25 per hour. Let's call that H. So all I have to do is divide by $8.25 an hour. And H is going to come out to be H is greater than or equal to 20 hours.